Let's next edit program 66, which we had seen in our last video session, and apply abstract classes to it. It's quite simple. A two-step process. As just shown in the last frame, we need to edit the virtual area function with a pure specifier, equals 0, so that the base class becomes an abstract class. And then, we will be deleting the base class objects. I mean, delete objects created from the base class, Polygon, and create references only via derived classes. Not to worry, nothing complicated. So here is our program code. It is similar to program 66. Differences are on line 10, where we edit the virtual area function with a pure specifier, equals 0. Then we remove base class object P on line 27, and other related statements. We retain the rest. So once again, let's quickly track the flow of program control. Here is the class Polygon. Protected variables, width and height are declared. Public function setValues is defined. It assigns values to width and height. Next we have the public virtual function, area, which has been assigned the pure specifier, equals 0. Class rectangle, that inherits from class Polygon is declared. Its area function returns the value of width times height. Class triangle, that inherits from class Polygon is declared. Its area function returns the value of width times height, divided by 2. In the main function on line 26, we instantiate object R for rectangle, and object T for triangle. As per line 27, pointer P1, pointing to base class Polygon, is assigned address of object R. So it points to block of polygon within the object R. As per line 28, pointer P2, pointing to base class Polygon is assigned address of object T. So it points to block of polygon within the object T. On line 29 of program code, we instruct pointer P1 to execute its setValues function. So in object R, setValues function executes. 4 is assigned to width, and 5 is assigned to height within this object. Similarly on line 30 of program code, we instruct pointer P2 to execute its setValues function. So in object T, setValues function executes. 5 is assigned to width, and 10 is assigned to height, within this object. Program control shifts to line 31, where we have instructed to output the area of a rectangle, by invoking the area function that pointer P1 is pointing to. And then on line 32, we have instructed to output the area of a triangle, by invoking the area function that pointer P2 is pointing to. The program ends. So we learned here to declare an abstract class, and point its virtual function to polymorphic functions within its derived class object.